we're asked to integrate the following in this problem, and we're going to use integration by substitution. Now, in this first problem, e to the t times e to the t minus 12, we've got to select a u and a du. Now, it only makes sense that since we know the derivative of e to the t is actually e to the t, we will select this to be u. And the reason we'll select this to be u is because when I take the derivative of minus 12, that becomes 0. And so the derivative of this is exactly e to the t. So if I let u equal e to the t minus 12, then du equals e to the t dt. And that's precisely what I have left over. So what I'm going to do is I'm going to interchange these two terms. And that way I have the integral of u du. And so that equates to u squared, oops, don't need the integral sign anymore. That equates to u squared over 2 plus c, which is equal to e to the t minus 12 squared over 2 plus c. So that's it for that guy. In letter B, we have a similar situation, except we notice this is an exponential function, and we notice that actually the exponent, 3t squared minus 7t plus 4, its derivative is exactly what I have as a coefficient here. So what I'm going to do is I'm going to let u equal 3t squared minus 7t plus 4. That means my du is equal to 6t minus 7 dt. Alright, well that's exactly what I have left. If I switch these two terms just to make it look a little prettier, 3t squared minus 7t plus 4 times 6t minus 7 dt, I can see that I have the integral of 3 to the u, and then this whole thing right here, that's du. So I know that the integral of an exponential function is 3 to the u over the natural log of 3 plus c. And now I can plug my u back in, so that's going to be 3 to the 3t squared minus 7t plus 4 all over ln 3 plus c. Finally, looking at the last problem, which is very, very similar, actually I think probably a little bit more straightforward in terms of the number of things going on. So I will pull that one up, and so here I'm going to similarly select my u to be the exponent, so it's going to be 4t squared minus 15, because I notice that if I take the derivative of that, I get du equals 8t dt. Now there's only one problem. I've got 4t, I need 4t, I have 8t. So what I'm going to have to do is multiply both sides of this equation by 1/2, so that I end up getting 1/2 of 8 is 4. So anywhere I see a 4t dt, I'm going to replace it with 1/2 du. So I'm just going to rewrite this integral times 4t dt, and I notice that here is my du, and so that gives me 8 to the u du. In a similar fashion as part B, this is going to be 8 to the u over the natural log of 8 plus c, and forcing in my substitution, I have 8 to the 4t squared minus 15 over the natural log of 8 plus c.